Hi there. Welcome to brilliantmaths.com, where every student has an opportunity to excel in math. Have you subscribed to brilliantmaths.com yet? Do well to subscribe. You'll be glad you did. Today's lesson is number basis, and this lesson is actually taken from Brilliant Maths Module 1. So get a copy and let's work together. We're converting from order basis to base 10. The number base we use is base 10, also known as decimal numeral. That means that we use 10 digits from 0 to 9. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In decimal numerals, we count in tens. There are other bases apart from base 10, like base 2, where you use only 2 digits. Base 4, you use 4 digits. Base 5, you use 5 digits. Base 8, you use 8 digits, and so on. Base 2 is called the binary system, and like I said, you only have 2 digits in it. And base 5 has 5 digits, 0, 1, 2, 3, 4, 5. So in base 5, we count in fives. And 5 in base 5 is equal to 10. We'll see how that works. So let's look at the first example. Convert 100101 in base 2 to the corresponding base 10 number. So this number has been written in base 2. As you can see, it has only 2 digits, 0 and 1. But we want to convert it to base 10. What would this number be equal to in base 10, in decimal numeral? So you write out the digits and then count the number of digits starting from 0. So 0, 1, 2, 3, 4, 5. Do well to write them under each digit so it will make your work easier. Next, we're going to multiply each digit by 2 to the power under. That means 1 times 2 to power 5 plus 0 times 2 to power 4 plus 0 times 2 to power 3 plus 1 times 2 to power 2 plus 0 times 2 to power 1 plus 1 times 2 to power 0. So we have multiplied each digit by the corresponding power of 2, starting from 0. The first digit will multiply by 2 to power 0. The second digit will multiply by 2 to power 1. The third digit will multiply by 2 to power 2, and so on, counting from right to left. Please take note of that. So next, we're going to expand and then add together. 2 to power 5 is 32. 2, 4, 8, 16, 32. 32 times 1 is 32 plus, this is 2 to power 4, but times 0. So the answer is 0. Plus, this is also 2 to power 3 times 0, so it's also 0. Plus, 2 to power 2 times 1, that is 4. Plus, we have another 0 here, because it's 0 times 2 to power 1. Plus, the last multiplication, 2 to power 0 times 1 is 1, because any number raised to power 0 is equal to 1. And 1 times 1 is 1. So now, 32 plus 4 is 36, plus 1, that is 37. So that implies that 100101 base 2 is equal to 37. You see how easy it is? But you just have to take your time. Whenever you're converting from a given base to base 10, write out the digits, number them from 0 to the end. Start from right and go left. Count all the digits and number them. Then write out the digits and multiply them by the base raised to the power underneath. It has to be the base from which you are converting. If you are converting from base 5, it will be 5 to power whatever number it has. And then you simplify and add them together. Try other examples. You'll get some more from Brilliant Maths Module 1. In this lesson, we want to look at how to convert a number from base 10 to another base. All right? Convert the number in base 10 to a number in another base. Example 1, convert 226 base 10 to number base 8. To be able to convert a number from base 10 to any other base, you use successive division. That's, you divide repeatedly by that base and record the remainder. Let's see how it works. So convert 226 to number base 8. So we write our number. The number is 226 in base 10. So we are dividing by 8 because we are converting to base 8. And then we'll record the remainder. If there's no remainder, you write a 0. So 8 into 22 is 2. 2 times 8 is 16. 22 take away 16, we have 6 left. So 8 into 66. So we'll bring down that 6. 8 into 66 is 8. And 8 times 8 is 64. So 66 minus 64 is 2. So we have a remainder of 2. We record our remainder there. Next, we're dividing, or rather we're continuing our division. 8 into 28. 8 times 3 is 24. So we have a remainder of 4. Next, 8 into 3 is 0. And then we have a remainder of 3. So to write our answer, we would count from the bottom up. The answer is 342 base 8. You count upwards from the bottom. So 226, 226 base 10 is equal to 342 base 8. Let's look at the next example. Convert 105 base 10 to number base 2. Again, we're using repeated division, but this time we're going to divide by 2 because we are converting to base 2. We'll set out the work. 105. We're going to record our remainders. And I'll just leave it as R. So we're dividing by 2. 2 into 10 is 5. 2 into 5 is 2. And we have a remainder of 1. Next, 2 into 5 is 2. Remainder 1 into 12 is 6. It's an even number. So there's no remainder. So our remainder is 0. Next, we'll just divide with 2 until nothing is left. 2 into 26 is 13. And the remainder again is 0. 2 into 13 is 6. 6 times 2 is 12. So this time the remainder is 1. Two into 6 is 3, and the remainder is 0. 2 into 3 is 1, and the remainder is 1. And then 2 into 1 is 0, and the remainder is 1. So our answer is, we're counting upwards. So our answer is 1, 1, 0, 1, 0, 0, 1 base 2. So that is equal to that. 105 base 10 is equal to 1101001 base 2. Let's check to make sure that the digits are complete. 110, 110, 1001, 1001, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Always count to ensure. Just make sure that your answer is correct. In this lesson, we want to convert between non-decimal bases. What do I mean by that? Converting from, let's say, base 2 to base 3, or from base 7 to base 4. And it's quite easy. To convert between non-decimal bases, first convert to base 10. Convert that number to base 10, and then convert the result to the required base. It's as simple as that. So example 1, convert 344 base 5 to number base 8. You remember how to convert from base 5 to base 10. Because first we'll convert from base 5 to base 10, and then we'll convert the number from base 10 to base 8, and we'll be done. So what do? Write out the number 3, 4, 4. Count it, 0, 1, 2. So 344 base 5 is equal to 3 times 5, which is the base, to power 2. You could put that in a bracket if you like, plus 4 times 5 to power 1, plus 4 times 5 to power 0. That's the use of this counting at the bottom, just to know the power to raise the base. So this becomes 3 times 5 to power 2 is 25, plus 5 to power 1 is 5, and 5 times 4 is 20. Let's still put this in a bracket, plus 20, plus 5 to power 0 is 1. So 1 times 4 is 4. So this gives us 25 times 3 is 75. Plus 20 plus 4. So I can practically say 75 plus 24. And that will be equal to 99 base 10. So the next is to convert 99 base 10 to base 8. And how do you convert from base 10 to another base? Repeated division, and then you record the remainder. So step 2, 99, we're going to divide by the base we are converting to. We're converting to base 8. And then we're recording the remainder. I like to write that as R. So 8 into 9, I have 1. Remainder 1. 8 into 19 is 2, 16. 19 minus 16 is 3. So the remainder is 3, and we record it. Next, we're dividing by 8 again. 8 into 12 is 1. 12 minus 8 is 4. So the remainder is 4. We're dividing. 8 into 1 is 0. And the remainder is 1. So our answer, we count upwards from bottom. We have 1, 4, 3, base 8. Therefore, 3, 4, 4, base 5. 3, 4, 4, base 5 is equal to 1, 4, 3, base 8. So the steps are very clear. When you need to convert between non-decimal bases, convert the number to base 10, and then convert the result from base 10 to the required base. Very simple. You just need to do more exercises so you can actually consolidate it. So try some more from Brilliant Maths Module 1. Here we want to solve equations involving number bases. 2, 3 base x is equal to 1, 1, 0, 1 base 2. Find the value of x. Solution. What you need to do is change both numbers to base 10, then you solve for x. So let's see, we have 23 base x. That becomes, if we count the digits, 0, 1. So we're doing 2 times x to the power 1 plus 3 times x to the power 0. I hope you remember that. Is equal to 0, 1, 2, 3. 1 times 2 to the power 3 plus 1 times 2 to the power 2 plus 0 times 2 to the power 1 plus 1 times 2 to the power 0. Great. So let's simplify. 2 times x is 2x plus 3 times x to the power 0 is 3 because x to the power 0 is 1. This is now equal to 2 to the power 3 is 8 plus 2 to the power 2 is 4. 2 times 0 is 0, so that goes to 0. And 2 to the power 0 is 1. So 1 times 1 is 1. So we have a simple equation here. 2x, we can take 3 to the other side, is equal to 8 plus 1 is 9. 9 plus 4 is 13. Or 8 plus 4 is 12. 12 plus 1 is 13. So I have 13, take away 3. Because 3 is crossing over to the other side of the equation. It's positive here, so when it crosses over, it becomes negative. So we have 2x is equal to 10. So 2x is equal to 10. And that gives us x is equal to 10 divided by 2. So x is equal to 5. So that implies that this number is actually 23 base 5. So 23 base 5 is equal to 1,101 base 2. We're still solving equations involving number bases. This example says, find the value of x in the equation. 132 base x is equal to 110 base 5. So the base of the first number is not known. So what do? You have a number in base x and a number in base 5. So first, convert both numbers to base 10. and then you'll be able to solve for x. And to convert to base 10, we're going to write out the digits, 132, and then we'll multiply by the base raised to the power of the count. Let me show you what I mean by that. 1 times x. In counting these digits, we start from 0. So that's 0, 1, 2. So x to the power 2 plus 3 times x to the power 1 plus 2 times x to the power 0 is equal to, we're now on the other side of the equation, 0, 1, 2. So that's equal to 1 times 5 to the power 2 plus 1 times 5 to the power 1 plus 0 times 5 to the power 0. So we'll simplify. X squared times 1 will give us x squared plus 3x plus 2 times x to the power 0 is equal to 2, because x to the power 0 is 1. 5 squared times 1 is 25 plus 5 to the power 1 is 5. 0 times 5 to the power 0 is 0, because 5 to the power 0 is 1, and 1 times 0 is 0. So let's see what we have here. We have x squared plus 3x plus 2 is equal to 25 plus 5. So if we bring 25 plus 5, which is 30, to the other side of the equation, we have a quadratic equation here. X squared plus 3x plus 2 minus 30. So now we have a quadratic equation. X squared plus 3x plus 2 minus 30. And plus 2 minus 30 is minus 28. So our equation is x squared plus 3x minus 28 is equal to 0. We need to factorize this quadratic equation. And to factorize, we need to find two factors of negative 28 such that when you multiply the factors, you will get minus 28. And when you add them, you will get positive 3x. And those factors are minus 4 and plus 7. Because minus 4 times plus 7 will give you minus 28. But minus 4 plus 7 will give you plus 3. The bigger number has to be positive because the middle term is positive. Take note of that. If you have forgotten how to factorize, go get our factorization lesson from Module 3. We have the videos there too. So let's work this out. We replace the middle term by those factors. So we have x squared minus 4x plus 7x minus 28 is equal to 0. So now we group them. I can simply group here so that we factorize. X is common here, so we take it out. X into x squared will give us x minus 4 plus 7 is common here, so we take it out. 7x divided by 7, we are left with x minus 4 is equal to 0. So now, x minus 4 is common to both brackets. So it's a common bracket, so we take it out. X minus 4. And then if you take it out, what is left? We're left with x plus 7. And that is equal to 0. So from this now, we know that x minus 4 is equal to 0, or x plus 7 is equal to 0. That implies that x is equal to 4 or x is equal to minus 7. We're looking for the base of a number, and the base of a number cannot be negative, so you disregard x equals minus 7. That means that this number is written to base 4. So x is equal to 4. So finally, we have our answer stating that 132 base 4 is equal to 110 base 5. You could check this out, convert both numbers to base 10, and you would see that they're actually equal. Very easy. You just need to practice. In this lesson, we want to learn how to add in other bases other than 10. Example 1, we're adding in base 2, and in example 2, we're adding in base 4. What you need to keep in mind when you're adding in other bases is that it's not base 10. So you can't get a number beyond the digits before the base. For example, if you're adding in base 2, your highest digit will be 1. So 1 plus 1, for example, in base 2 is 10. We'll see how that works. We have 1, 2, 3, 4, 5 digits. 1, 2, 3, 4, 5 digits. I need to be able to align them properly. So 1, 0, 1, 0, 1, base 2, plus 1, 1, 0, 1, 1, base 2. So let's add and see what we'll get. 1 plus 1 is 2. So since the base is 2, we can't have 2, so we divide 2 by 2. So 2 divided by 2 is 1. So 1 plus 1 is 2. And 2 in base 2 is 10. Because you divide 2 by 2 and you get 1, remainder 0. So that's a 0. And we carry 1. So 1 plus 1 again is 2. 2 divided by 2 is 1. Remainder 0. Put down the remainder. We carry 1. 1 plus 1 again, 2. Put down 0. Carry 1. 1 plus 1, 2. Put down 0. Carry 1. 1 plus 1 plus the 1 we have carried on is 3. 3 divided by 2 is 1, remainder 1. So that gives us 1, 1, and is in base 2. And that's the answer. 1, 1, 0, 0, 0, 0, base 2. Example 2, we're adding these two numbers. 3, 2, 3, 1, base 4, plus 2, 3, 1, 2, base 4. Both numbers are in base 4, so the highest digits we can have here is 3. Anytime we get a number higher than 4, we divide by 4 and write down the remainder. So 1 plus 2 is 3. The answer is going to be in base 4, so I can as well just write it. 3 plus 1 is 4, and 4 in base 4 is equal to 10. So we put down the 0, because 4 divided by 4 is 1, remainder 0. So we write down the remainder 0, and we carry the 1. 1 plus 2 is 3. 3 plus 3 is 6. 6 divided by 4 is 1, remainder 2. So we write the remainder 2, and we carry the 1. Again here, 3 plus 1 is 4. 4 plus 2 is 6. 6 divided by 4 is 1, remainder 2. So our answer is 12203 base 4. So just take note of the number base you're adding in and make sure that once you get a sum that adds up to that base, you have to divide it by the base, write the remainder, and carry over the 1. It's actually very easy. You just need to do more examples. And you'll get that from Brilliant Maths Module 1. Let's look at how to subtract in number bases other than base 10. So in this example, we want to subtract in base 5. 431 base 5 minus 212 base 5. So let's see. 431 base 5 minus 212 base 5. What you need to know is when you're subtracting in a different number base other than 10, when you borrow or trade, the one you borrow is not equal to 10. Rather, it's equal to the value of the base you are working in. So take note of that. 1 take away 2, we can't, so we borrow 1 from the 3, and that one we borrow is not equal to 10, rather it's equal to 5. So 5 plus 1 is 6. 6 take away 2 is 4. We're working in base 5. We're left with 2 here because we've borrowed 1. 2 take away 1 is 1. And then 4 take away 2 is 2. So that subtraction gives us 214 base 5. Subtraction is actually as easy as addition. You just need to keep in mind the base you are working in. When you trade or you borrow, the value of what you borrow is equal to the value of the base you are working in. Here we want to quickly learn how to multiply in number bases other than base 10. In the first example, we're multiplying in base 8. In the second example, we will multiply in base 4. All you need to do is know your tables and keep that base in mind. Keep the number base in which you're working. So example 1, 3 base 8 times 4 base 8. So we have 3 base 8 times 4 base 8. We know that 3 times 4 is 12. So 3 times 4 is equal to 12. But to write 12 in base 8, we'll do 12 divided by 8. And 12 divided by 8 is equal to 1 remainder 4. So we write the remainder 4, it's 1 remainder 4. Let me write it out so you're not confused. And 1 remainder 4, remember that you start writing the remainder first. So that is equal to 14. So we can say that 3 base 8 times 4 base 8 is equal to 14 base 8. Exactly. So 3 base 8 times 4 base 8 is 14 base 8. Let's look at the second example. 23 base 4 times 12 base 4. This is 2 digits by 2 digits multiplication. So it follows the same steps. 23 or 23 times 12. We're working in base 4. So keep that base in mind. So 2 times 3 is 6. 6 in base 4. So we have to divide 6 by 4, remainder 2. So that's 1, remainder 2. So we write down the 2 and we carry the 1. 2 times 2 is 4, plus 1 is 5. We divide 5 by 4 and we have 1, remainder 1. So we're writing the 11. Next, we're multiplying by 1. Remember to put that 0 placeholder. 1 times 3 is 3, and 1 times 2 is 2. Then we add. Let me rule a line to separate the working. What is this equal to? 2 plus 0 is 2. 3 plus 1 is 4. 4 divided by 4 is 1, remainder 0. So we write the 0 and carry the 1. 1 plus 1 is 2. 2 plus 2 is 4. 4 divided by 4 is 1 remainder 0. So we write the 0 and the 1. So 2, 3 base 4 times 1, 2 base 4 is actually equal to 1002 base 4. In multiplying, or rather when multiplying in other bases other than 10, you just have to keep that base in mind so that you constantly divide your sum or your totals by the base, write the remainder, and carry over what you have. In this lesson, we want to work in number bases greater than base 10. So how do we do that? To work in a number base greater than 10, we need to create extra digits or symbols. Why do I say so? Base 2 system has 2 digits, 0 and 1. Base 8 system has 8 digits or symbols, 0, 1, 2, 3, 4, 5, 6, 7. They make out the digits for base 8 system. Base 10, we know the digits already from 0 to 9. Those are the 10 digits that make up the symbols for base 10. So assuming we want to work in base 12, so base 12 system should have 12 digits. You agree with me? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We need a 10 and 11. And since we can't repeat the 0 and the 1, let's call the 10 T and the 11 E. So those are the digits, the 12 digits we need to work with in base 12. So let's look at the first few numerals, the first few numbers in base 12. 0 is the first. We have, so these are actual numbers now. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have our T. And we have our E. And then 10. Because 12 in base 12 is equal to 10. And then 11. So this is actually 13 in base 10. All right? So 11, 12, 13, 14, 15, 16, 17, 18, 19. And then 1 T and 1 E before we get our 20 in base 12. And so on. Let's look at how we can work in this base. Here we want to convert from base 12 to base 10. So the first example says convert 876 base 12 to base 10. You remember the process. We write out the number, 876. Remember to count from 0, 0, 1, 2. So we need to multiply each digit by the base raised to the power of the count. So that's equals 8 times 12 to power, this is raised to power 0, power 1, and power 2. So it will be 12 to power 2. Put that in a bracket, plus 7 times 12 to power 1, plus 6 times 12 to power 0. All right? Then we have 8 times 12 to power 2. That is 8 times 144 plus 7 times 12. 7 times 2 is 14, carry 1. 7 times 1 is 7, plus 1 is 8, plus 12 to power 0 is 1, and 1 times 6 is 6. What is 8 times 144? Let's do that in our calculators. 8 times 144 is 1,152 plus 84 plus 6 is 90. So 1152 plus 90 equals 1,242. And this is now in base 10. The second example, we want to convert 47e base 12 to base 10. Remember that T is for 10 and E is for 11, all in base 12. So we write out the number 47e. We count from 0. 0, 1, 2, 3. So 4 is going to multiply 12 raised to the power 3. Remember that? So 4 times 12 to the power 3 plus T. But we know that our T is what? Our T is 10. So we can then write it 10 times 12 to the power 2 plus 7 times 12 to the power 1 plus E times 12 to the power 0. And we know that our E is 11. 11 times 12 to the power 0. I like to put this in bracket. Next, let's simplify. We're going to multiply 12 to the power 3 by 4. And 12 raised to the power 3 is equal to 1728. And 1728 times 4 would give us 6912 plus 12 to the power 2 is 144. 144 times 10, you just attach a 0, plus 12 times 7 is 84, plus 12 to the power 0 is 1. 1 times 11 is 11. So we'll find the total. 6912 plus 1440 plus 84 plus 11. And that is equal to 8,447 in base 10. So we mean that 4, let me write that in a different color. So we mean that 4T7E base 12 is equal to 8,447 base 10. All you need to do is take your time to work this out. You get more of these examples and exercises in Brilliant Maths Module 1. Subscribe to brilliantmaths.com. There are lots and lots of resources for you. My name is Ngozi Orevogene, and always remember, maths is fun. You